How's everyone doing today? Oh, we are so excited. Thanks everyone for joining us. I know we're a little bit slow loading in. Thanks everyone for joining us today. We are going to be talking about cloud-native DevOps with Kubernetes and Serverless. I think I just hit buzzword bingo. So like mark your bingo cards. Today we'll be starting with cloud-native app dev, data and findings. We'll be running us through that. And then Russel will be chatting through paths to cloud-native with some dope demos. Stephanie will have a demo for going serverless, and then we will all be chatting about fireside chat. So has anyone here heard of the State of DevOps report? Yay! This is my favorite nerd fun. What the State of DevOps report is research, and now y'all are like, no, I left school. I promise it's fun. What this does is it helps us understand how to drive elite performance. This helps us know how we can develop and deliver software with speed and stability so that we can deliver value to our customers, to our stakeholders, to our organizations. And it does it in a way so that we know what capabilities and practices are really important. So we know what to focus on in our work, so that we know what resources we should be focusing on, so that we can improve our own technology and organizations in the best, smartest ways. So we aren't wasting our time, so we aren't wasting our resources. And so that we know how we can be an elite performer. And everyone's like, elite performance, what does that mean? So that we can optimize speed and stability, basically. And what we found is that speed and stability goes together. You don't have to slow down to be stable, or conversely, you don't have to be less stable in order to go fast. And they go together at the high end and at the low end. Now, when I say speed and stability, what am I talking about? Speed is deployment frequency. It's lead time from commit to deploy. Stability is MTTR and change fail rate. Now, when I compare those highest performers, those elite performers, and the low performers, this is what we see in this year's research. We see 208 times more frequent code deployments. I see 106 times faster lead time from committing code to code running in production. I see over 2,600 times faster time to recover from incidents, and 7 times lower change fail rate. What does this mean? Why does it matter? It means faster feature delivery. So again, we can deliver value to our customers. But it also means more than that. It means that I can keep up with compliance and regulatory changes. It means I can update my infrastructure. It means I can deliver quality. It means I can keep up with security. It really is a holistic picture. So it really is important. Cloud is also a key component of this. And it's a differentiator for elite performance. Our elite performers are 24 times more likely to have met all cloud characteristics. And it's interesting because when I started researching this last year, we saw this, and we decided to dig into it because so oftentimes I talk to sometimes executives, and they're like, well, I did the cloud and nothing changed. Or developers, and they're like, well, we did the cloud, but nothing changed. I don't know if anyone's seen this before. But the challenge is that we actually have to be doing cloud. So what we found is that when I started doing the research, we were asking people if they were doing the cloud, and then we dug into the 5 characteristics that make cloud actually the cloud, and this is defined by NIST, National Institute of Standards and Technology. Only 29% of respondents had actually met all 5 characteristics. Here's what it is: on-demand self-service. You can't put it behind a ticket that requires human intervention. Okay? Doesn't count. Broad network access. You have to be able to access your cloud from several different kinds of devices. Resource pooling. So you have a bunch of resources that you pool and use what you need. Rapid elasticity, bursting like magic. Burst up and burst down, okay? Also measured service. You only use what you need, and you only pay for what you need. So cloud and using the cloud and having an architecture for the cloud means that you have all 5 of these, and it really drives performance. So what we've seen is that we really have fundamental principles for success that if teams follow these, it really does drive performance. So here are some of these that we see. So one is moving from monoliths to microservices. And in the research, we've seen this for a few years. This really is having a loosely coupled architecture. And I've seen this in my own work. My very first job was as a mainframe programmer. And it's tough if we have something that's tightly coupled and we have to deploy these massive changes all at once, right? So if we can have a microservice application, we can have a logical unit of functionality that can really just exist independently, right? A second one is picking a technology with deep open source roots. And we've seen for the last couple of years that the highest performers are adopting open source technologies because it allows us to do a lot of things, right? We can draw on the knowledge of a broader economy inside and outside of our organization, right? We can have a knowledge base that's broad. We can have a recruiting pool that's broad. We can really drive performance in a lot of different ways. It gives us freedom. It gives us resources that are all over the place. It gives us better security, too. Third is we can automate smartly. This allows us to reduce tool, and it improves speed and stability and performance throughout our entire pipeline. Okay. So what this allows us to do is to really adopt our principles so that we can be agile and move faster. Okay, I've talked too much. Who wants to see a demo? Like, right? This really is my favorite part. So I am now going to be handing this off to Russel Wolf. Please help me welcome Russel to the stage, who will be talking about paths to cloud native.
Thanks, Nicole. Hi, everyone. I'm Russel Wolf, the product manager for Cloud Code, and I'm here to talk to you about the paths to cloud native on Google Cloud. There are essentially 2 approaches to cloud native app development: Kubernetes and serverless. It really boils down to how much control you want over the stack versus how much you want to be able to focus entirely on your business logic. With serverless, you get an incredibly powerful stack, and it lets you focus on your business logic by providing a higher level of abstraction. With Kubernetes, on the other hand, you get the higher granularity and control over the stack implementation. Google provides end-to-end tooling for both serverless and Kubernetes. It starts with Cloud Code, which lets you write, debug, and deploy your Kubernetes applications. With plugins to IDEs like VS Code and IntelliJ, Cloud Code makes it really easy to work where you work today. Cloud Code also comes with pre-configured sample applications, so you can be up and running in seconds. Once you've actually created your code, you need to build it. And so Cloud Build's there as a completely serverless CI/CD platform that lets you build, test, and deploy applications in the cloud at any scale. Cloud Build recently took the leading position in Forrester's Wave analyst report. Once you've built your containers, you need to store them somewhere. So you can store them in Container Registry. It makes it easy to store, manage, and secure those containers before you get them deployed. Once you have your containers in the cloud, you then get to choose whether you want to deploy them to GKE or a serverless platform like CloudRun. If you choose GKE, you get a managed, prod-ready environment for you to deploy your containers to Kubernetes. If you choose serverless, on the other hand, you get a fully managed serverless platform that abstracts away all that infrastructure and lets you just run your code. Finally, once you get your code into production, you have the Stackdriver suite of tools that enables monitoring and logging, among other capabilities. There are three guiding principles for Kubernetes development that we like to focus on. The first one is keeping it simple. We want to get developers productive as quickly as possible. That means simplifying and optimizing the developer loop. That way, developers can iterate faster locally, as well as once they've deployed their code to production. And we do that with deployment best practices. Next is continuous security and feedback. We want to move critical practices earlier in the development lifecycle. That way, developers can identify and prevent defects sooner, which means you waste less time later in the process. Finally, we want to help you implement everything as code and containers. We use Git as the source of truth and for version control. We package applications as containers given the isolation and consistency benefits you get. Additionally, all your toolchains, runtimes, and your applications are then delivered and packaged as containers. So let's start talking about that inner development loop. The inner dev loop refers to the time it takes developers to make a change and see that feedback, and that can happen when you're fixing a bug, refactoring code, or implementing a feature. Cloud Code's continuous development allows you to rapidly rebuild and redeploy your code anytime you make a change, saving you from having to rebuild, retag, push that registry, and then get it deployed every time. It just happens, and we have intelligence in there that makes it happen a lot faster than if you were to do it manually as well. Next, once your developers are confident that the code change is what they want, you want to get it pushed to production. And this is where Cloud Build takes care of CI/CD for you. This involves steps like security scanning, integrating in with pull requests and showing results there, and things like binary authorization and signing. And once your code is deployed, again, Stackdriver provides that observability that you need to ensure that it's running correctly in production through things like logging and monitoring. Now, as a developer, you want to get continuous feedback and security on your code, from the time you write it to the time that you commit it, and then finally releasing it. Google Cloud Developer Tools for Kubernetes provide you with fast feedback with baked-in security and compliance. Here's how we do it. As soon as the build is created, build results and logs are provided directly with the tool that you're using, such as a GitHub pull request. Vulnerability scanning then goes through and finds CVEs in the images that get built. Then, during release, binary authorization makes sure that only properly signed code that conforms to your organization's policies can actually be deployed to production. If you try to deploy an image that hasn't been signed according to binary authorization's requirements, Kubernetes will just deny it and not allow it to run on a production cluster. Finally, those logs are available to devs at the very end in case something does go wrong, so you can go back and fix it. So you can see that the whole end-to-end has these insights. Finally, Google helps you implement everything as code and containers. One great example of this is with Cloud Build. Cloud Build gives you the full flexibility to define custom build, test, and deployment steps with the Cloud Build YAML for CI/CD. Each build step is executed as its own unique container that can run any task that you need as part of the build. Cloud builders are provided with common language runtimes inside of them, and also various tools as well. So you might have one specifically for performing Docker containers or for cloud SDK tasks. And finally, enterprises can then tie their legacy and homegrown tools as part of that build process by stringing together these various containers that are purpose-built and isolated. As you may have heard in the keynote today, Cloud Code is now generally available. Cloud Code makes it easy to write, debug, and deploy your Kubernetes apps. In the keynote demo, I focused on two key features of Cloud Code. The first is rapid evaluation of Kubernetes, and the second was tight integration with CI/CD systems. With the Cloud Code GA, we've also matured all of the other features across IDEs. Please welcome Etan onto stage, and he's going to show us how Cloud Code enables Kubernetes development inside the IntelliJ IDE.
All right, thanks, Russell. So now it's demo time. There we go. All right, so I'm going to now demo how Cloud Code can simplify Kubernetes and CloudNative development. As you can see here, I'm in IntelliJ, which happens to be the IDE I use most frequently. Cloud Code ships with a set of starter templates to help you get started quickly on Kubernetes in various languages, as you can see here. The Cloud Code also makes it easy to bring in your existing applications, like this guestbook app I have. So this is a Java application with a few services, a front end, a back end, and a Mongo service. And it's written using the Spring Boot framework. So let's open it up. So this application is new to Cloud Code. Normally, I would have to spend a bunch of time figuring out how to run and debug my application on Kubernetes. And this could mean searching around the web and bringing in a bunch of different tools and processes. But notice this notification that I have here, prompting me to create a couple new run targets. So I'm going to accept the prompt here. And that's it. At this point, we're ready to run and debug our app on a Kubernetes cluster. But let's dive a little deeper first. So notice the Cloud Code created a couple run configurations for me. So develop on Kubernetes and run on Kubernetes. I'm going to look a little closer at develop on Kubernetes. And I'll point a couple things out here. So up here at the top in the first setting, Cloud Code will watch for changes in my source code and automatically surface them on the cluster whenever something changes. Another thing I'll point out here, down in deployment, Cloud Code makes it super easy to switch between my available clusters. As you can see here, right now I'm pointing to my GKE cluster in the Europe West zone, but I can easily swap to another cluster, like my local Docker desktop cluster, or I can set up a Minikube cluster and point to that, or any one of my other GKE clusters. In fact, Cloud Code works with any Kubernetes cluster. The plugin also has this handy cluster explorer, where you get a top-level view of your clusters. You can see which one is active and easily switch between them. You can even drill down into your resources and view things like your pods, deployments, replica sets, services, and so on. So at this point, I want to debug the application, and it's as easy as clicking the debug button right here. So Cloud Code is now building my application. It's building my image, it's tagging it, it's pushing it to a container registry, and it's deploying my app. It's also instrumenting the application for debugging. So if you ever tried to do all of this manually, you know this could be hours of setup, but Cloud Code streamlined this into a single action for me. So let's look at the logs. It looks like the application is started up, or nearly started up. And as you can see here, we have a couple debuggers now attached, one to my front-end service and one to my back-end service. Now I want to open up the app and test it out to make sure everything looks correct. So I'm just going to open up, or I'm going to open up the app by clicking on this link right here to open up my front-end service. Oops. All right, so here's our application. As you may have noticed, Cloud Code took care of port forwarding the app to localhost for me so that I can easily test things out. So this is a guestbook app, so let's first just add a few entries into the guestbook. And let's add a couple more. Just name, message, and then one last one. So this looks okay, but notice that my new messages are showing up at the bottom here. So if I add a bunch of messages to the guestbook, the new ones could get lost at the bottom. So ideally, I'd like them to show up on the top. So let's go back to the code and see if we can debug and fix this. I'm going to open up my backend controller and take a look at the get messages endpoint where I'm fetching all the messages from my Mongo service. And I'm going to set a breakpoint here on the return value, then go back to my guestbook and refresh. And as you can see, we hit a breakpoint. So now I can view my local variables, step through code, evaluate expressions, and so on. But let me remind you, this application isn't running locally. It's running inside of a container inside of a Kubernetes cluster on GKE. Yet I'm able to debug the code as if it were running locally with no added setup. So let's take a look at our messages array, and I can see the 3 entries that I added right here, and indeed they look like they're in the incorrect order. So I'll just open up the expression evaluator and take a look at our repository service. And as you can see here, I'm calling the find all service, but I can also see here that we have one that takes in a sort object. So that looks like what we want. I have the code snippet that we need actually right here at the top. So I'm just going to copy it, paste it into the method, and then pass the sort object into my repository service. And we'll step out of the code and remove the breakpoint. So at this point, I could wait for everything to get rebuilt and redeployed. But since this is a Java app and Cloud Code utilizes language-specific functionality like hot swap, I don't have to wait that long. So I'm just going to go to build and recompile the class. So IntelliJ is now going to recompile my controller class and reload it on the fly. So this feature should be pretty familiar to Java developers, but the cool thing here again is that this is not an app running locally. It's running on my remote GKE cluster. So I got a notification here that my backend class was reloaded, and now I should be able to test things out. And if I go and refresh, we can see it shows up in the correct order. And let's just add one more message to confirm. And it looks like it's showing up in the right order now. All right, so back to my application. Oh, one thing to point out is that I can go here into my Cluster Explorer and then view my resources that are deployed. So you can see here that I have 3 pods, and they're all 3 of them are healthy. And I can do things like stream logs from the pods, describe the resources, and so on. Cloud Code also supports some more advanced scenarios, like non-default kubeconfig files. So right now I'm just using my default one, but I could easily point to a different kubeconfig file or load a new one. All right, so now we're happy with the app. I'm just going to kill the development session. And as you can see here in the logs, Cloud Code is taking care of cleaning up my deployments and my services for me. But I can easily configure it to leave them running on the cluster if I wanted to. Cool, so now let's get this application into production. And to do this, we should probably be using a CI/CD pipeline. This can be tricky to set up, but Cloud Code helps here with some declarative configuration and cloud build. So let's first create a new file, and I'm going to call it trigger.yaml. Add it to version control. And now using built-in snippets in Cloud Code, I'm going to create a cloud build GitHub push trigger, which tells Cloud Build to build my application on every push to a branch in my repository. So let's just give it a name. I'll call it push trigger, the owner of the repo, which is me, and the name of the repository, which is guestbook next London. And that's it. And you can see here we're pointing to a file called cloudbuild.yaml, which tells Cloud Build how to build my application. I had already created this ahead of time, and we happen to be using Scaffold to build and deploy the app. But if I didn't have it, again, I could use the built-in snippets in Cloud Code to quickly author one. So now let's create the trigger. I'm just going to right-click on the trigger.yaml file that I created already and click Apply Trigger. Now I'm going to confirm my GCP project here and click OK. So the trigger is now being created, and it looks like the trigger was created successfully. So all that remains at this point now is to commit my code fix, push it to my repo. Cloud Build will then pick up the change, and then build and deploy my app to production. And that concludes the demo. All right, just to quickly recap what we just saw. So if you're just getting started with Kubernetes, Cloud Code ships with a set of starter templates to help you get started quickly. But if you have an existing application that you'd like to bring in and optimize for Kubernetes development, we have support with snippets and automatic setup. Your inner development loop is sped up with Cloud Code via automated build and deploy steps. You also get the full power of debugging your apps live in a Kubernetes cluster, as if they were running locally. Cloud Code also works with more advanced language features. For example, I demonstrated hot swap in Java. And you can easily deploy your code to any local or remote Kubernetes cluster right from the IDE. You can get insight into your cluster and its resources using the Kubernetes Explorer that I showed. And finally, our snippets make it much easier to set up your CI/CD pipeline. So, in summary, across both the JetBrains family of IDEs and VS Code, as you saw earlier in the keynote, Cloud Code helps you simplify Kubernetes development. So now, please help me welcome Stephanie to talk about serverless and CloudRun.
Thanks, Etan. All right, so you are all probably very familiar already with what serverless provides and its operational model. You pay for what you use, and there's no server management. But what's also really interesting here is the programming model. It's serviceful, and it's event-based. And what that means is that you are consuming fully managed services without dealing with things like setup, infrastructure management, and things like load balancing, sharding, etc. And at Google Cloud, we offer full-stack serverless products, including machine learning, data analytics, database and storage, and DevOps, as Russel and Etan covered. You might also be familiar with some of our compute serverless products, like App Engine and Cloud Functions. But as you know, containers have become the de facto standard for packaging your code, and Kubernetes for deploying your applications. These give developers scalability, flexibility, and productivity, but there are also multiple steps involved in the workflow, from the time that you commit the code to the time that you can actually access the application. This includes things like creating a Docker file with all the dependencies, building the container image, and then uploading that container image to the container registry, creating a Kubernetes YAML file for the deployment with the container, creating yet another YAML file for exposing the deployment as a service, deploying the pod in the service, and then finally accessing the application through the endpoint. So developers have been asking for a serverless tool that goes beyond simple functions and one that supports containerized environments. And they're usually faced with a really tough decision. Choose between the speed and the ease and velocity of serverless or the flexibility and the portability of containers. But at Google Cloud, we really think that you should have the best of both worlds. So introducing CloudRun, which you may have heard we announced in beta last year, and now it is generally available. So CloudRun brings serverless to containers, and it effectively shortens the path between the time that you can commit your code to actually accessing your application. It lets you run stateless containers that are invocable via HTTP requests. CloudRun auto-scales your application up or down, and even back down to 0 when you're not running your workloads, because it is request-aware. You only pay for the resources that you are using. So if your application is not running, you're not paying anything. And when your application is running, you are paying down to the nearest 100th millisecond. You can also run any binary or language because you're deploying using containers. And with the help of tools like Cloud Code and Cloud Build, developers can write their code, test it locally, and deploy it as a container image on Google Cloud using CloudRun without the intervention of DevOps teams. So this is modern software development, the way that you want to do it without the hassle. And this is part of our mission to bring the cloud to you. So behind the scenes, CloudRun is built using Knative, which is an open source project to run serverless workloads that we deployed and launched last year. It's an open API and runtime environment that lets you run your serverless workloads wherever you choose. So this means that you can actually deploy the exact same microservice to any Kubernetes cluster running either on GCP, GKE, on your self-managed Kubernetes cluster, and that can be on-premise or even on the cloud, even another cloud provider. And just to restate this, because I think it's worth hearing, you can run your serverless workloads on any Kubernetes cluster running Knative. So with this portability, you can easily run these workloads with tools that you're already using to run and deploy your containers on Google Cloud. So CloudRun comes in two flavors: fully managed CloudRun and CloudRun for Anthos. So fully managed CloudRun is fully managed with no cluster as a backend. So you have things like usage-based pricing, auto-scaling, and no infrastructure management. You simply package your code into a container image, upload it to the container registry, and then deploy the container image to CloudRun. CloudRun for Anthos lets you run containers on GKE as serverless code. So instead of a fully managed infrastructure, you can deploy your code on an existing GKE cluster that you've already created. That way you can have things like custom machine types, use GPUs, and run it on Google Cloud or on-premise. This is perfect if you're already running a Kubernetes cluster and you want to configure specific hardware requirements for your serverless containers. All right, so to demonstrate this, I'm going to actually be deploying an application that converts Word documents into PDFs. So does anyone remember OpenOffice? Some? They're here and there. OK, I see a few people. So it's somewhat of a legacy application, and I'm going to show you that I can just deploy it to a container and run it as a serverless workload. All right, so what I'm going to do here is head over to the CloudRun deployment page. If it loads. Let me switch over, potentially. This one might be faster. All right, so once I click Create Service, sorry about that. And once I'm here on the deployment page, I can select my container image URL that I've already uploaded to the container registry. So here I'm selecting CloudRun fully managed. All I have to do here is click Create. And what it's going to do is it is going to upload the container image, make sure that it's get started, and it will start to route traffic over. And it will soon be able to just give us a stable and secure HTTPS endpoint. And see if this loads. Maybe I'll switch back. That's not what I want. All right, so this is the endpoint that it's been able to give us. And once I click it, it'll give us the OpenOffice application that converts our Word documents into PDFs. So let's go ahead and test it out with a document. Sure you're all familiar with this. So while it's converting, OpenOffice is not exactly a modern piece of software. It's about 15-year-old binary, and it's about 200 megabytes. And we were able to deploy that as a serverless container just with a few clicks. So let's go ahead and take a look at the code real quick. So it's a very small Python file here, and what it's doing it is listening for incoming HTTP requests, and then using OpenOffice to convert the document into a PDF. And then Alongside, we have also a very simple, straightforward Docker file. It starts by specifying our base image, which is the official Python-based image, and then using and installing OpenOffice and any startup commands that we have included. And while it's deploying, in the case that you have an application that needs to scale up very quickly, CloudRun can actually auto-scale to thousands of instances or containers in just a few seconds. Now, in the case that you do want a little bit control and you want to run it on your own GKE cluster, or again, as I mentioned, deploy using GPUs, then we can go ahead and try out CloudRun for Anthos. So it's the exact same deployment page and developer experience. We're going to choose the same microservice. And instead of selecting CloudRun fully managed as a region, you simply need to select CloudRun for Anthos. And here I have an existing cluster that I've already created. Again, I'm clicking Create. And again, it is deploying on that GKE cluster. And it's going to give us a URL and HTTP endpoint in return, as you can see here. And here I have it now running on Anthos. And just to show you real quick, this is what container registry looks like. Once you have packaged your code using Cloud Build, for example, is what I've done here in this case, you can upload it to container registry, and it becomes available as a selected image that you can deploy on CloudRun. So go back to the slides real quick. Demo has concluded, so I just need to go back to the slides. Perfect. All right, so just in conclusion, what you just saw, we were able to just simply deploy our container. In just a few clicks, you're able to get the application up and running in production. You can use any stateless container, as I mentioned, invocable via HTTP requests. You have a URL in seconds. It's one developer experience, whether you choose to do fully managed CloudRun or CloudRun for Anthos. You have consistent APIs and tooling with the rest of the Google Cloud ecosystem. It's portable with Knative, which I think is very salient, and you're paying for exact usage. So overall, CloudRun is giving developers what they love about serverless. There's no infrastructure management, serverless in nature, and you get to focus on the code in conjunction with tools like Cloud Build and Cloud Code. So next, I'm going to bring back on Russel and Nicole so that we can jump into that quick fireside chat.
OK, thanks, everyone, for demos. So I'm sure we have questions. So I'm going to field questions, but that I've already written. Sorry, y'all. You can find us later. So a question that I get a lot when I meet with developers and with managers and with executives is, why do we have competing development platforms? I hear serverless, I hear containers, I hear Kubernetes. Why do we have this competing thing? How do I even choose?
Well, as I mentioned earlier, part of it is whether you really want to focus on your business logic or whether you want a lot more control over your infrastructure. Regardless of which one you really choose there, though, you're still going to use the same tool chain. You're still going to package as containers. You're still going to use Cloud Build, container registry, and tools like Stackdriver, monitoring, and Stackdriver logging. You also get benefits in both cases of Google managing your operating systems, as well as Google's global network, allowing you to deploy your apps anywhere in the world and have high speed and efficiency.
Yeah, and then in terms of just some of the unique points, I think it really comes down to whether you're running stateful or stateless applications, as I mentioned earlier. And it also, in addition, boils down to the type of workload that you're actually running. So for example, if you're running an e-commerce application that has high peak times during specific time frames, then that's a great use case for serverless because of the ability that it allows you to scale back down to 0 and not pay when you're not actually using it. On the flip side, if you're running a very consistent application that's high volume based with a lot of predictability, then you may want to consider running that on GKE.
OK, so it's more complementary than competing.
Right.
Yep.
OK, so somebody take a picture of this and tweet it so I can find it later. I like this summary. OK, another question I get a bunch. I keep hearing a lot about cloud native. What are some guiding principles that y'all use and suggest to follow?
I think the first one is you want to focus on building microservices and getting away from the monoliths that I think we all were building in the past. Microservices allows your code to be managed independently, and even more so, it allows your code or your services to scale granularly. So, second, I'd say use everything as code. That way, everything can be automated, tracked in version control, and rolled back independently as necessary. Similarly, you probably want to use everything as containers. That way, you can leverage your own pre-configured tool chains and focus really on the code and not redefining these tool chains each time.
Yeah, and then automation, for me, is a really big one. So your CI/CD should incorporate fast feedback loops via per branch CI and deployment automation. So, for example, rather than thinking of automation from end to end, every time a branch change occurs, then CI should have set up. So you get continuous validation. Again, whenever change is committed, you get feedback, and your CI system is then scalable and serverless. And then in terms of proactive security and compliance, you should be building in isolation so that you have continuous security throughout the entire process. So again, that's alongside automation. You should have compliance built into that automation as well. So rather than thinking of security as an afterthought, you should be building compliance into your actual pipeline and making sure that builds can actually go through until compliance is met. And then lastly, scalable. So as I was talking about with serverless, the ability to scale back down to 0 is a really key point, and then also scale back up to meet demand. So that way, you're only paying for what you use. Again, that's a key principle of serverless. And again, rapid elasticity, bursting up and down, and just basically reducing your resource consumption. And actually, Dora is the part that you worked on that also talks about some of these principles, right?
Yeah.
Like elasticity and measured service.
We've seen a bunch of that. And for so many of these things, I'm sure y'all have seen a bunch of this in your own work, right? Like use of automation, good architectural patterns. Automation makes things repeatable and consistent. I love hearing these in terms of intuition and stories, but as a researcher, I need proof. And so we've seen so much of this show up in our own evidence in Dora's research. So the nice thing is that everything here we've seen drives performance outcomes as well. So this sounds super hard. This sounds like a lot to do, right? So what are some initial steps, or where can we all start?
There are a lot of resources that Google Cloud offers for adapting to cloud-native development. The first is with our developer training and certifications. You can find free hands-on training that we offer online, as well as on-demand courses with things like Quick Labs or Coursera. And finally, we have in-classroom training offered by many of our partners as well. Second, I'd say reach out to your technical account managers. By working with them directly, you can help get assistance defining your business requirements and then coming up with a roadmap that aligns with Google's. Third, you can work with professional services consulting that Google offers to really build whatever it is that you're looking to build. And finally, you can work directly with Google support engineers, and they can resolve whatever problems you have.
Cool. So like I mentioned earlier, I started on mainframes. And I work with lots of enterprises who say, like, but what if I'm an on-prem shop? Do we have tips for that?
Yeah, and that's a really good question and one that we often get. I mean, I think cloud tools can definitely help you offload your work, but it really depends on where you're at with your migration journey. So for example, you might be starting to offload some of your applications and systems, and then perhaps later down the road, you decide to completely do a re-architecture of select applications. So just diving into that a little bit more. So with a lift and shift, as you probably know, what you're doing is you're actually rehosting your existing applications in the cloud, and you're lifting existing applications into, for example, Google Cloud. And then next up, you might be considering deploying your application on the cloud and then supplementing it and optimizing using some of the cloud-native functionality. So you might be doing things like taking advantage of our CI/CD tools, for example, eventually replacing Jenkins with Cloud Build, and then maybe taking advantage of our database offerings as well, and then monitoring like Stackdriver that's already built into many of our offerings. These tools can actually work really well without re-architecting, and it can work in conjunction with your existing tool set. And then lastly, if you decide to re-architect applications, you're able to leverage the benefits of containers, microservices, et cetera.
I love the fact that there's something that you can do anywhere that you are, right? To kind of move forward. So what's something that we can do today as we step out from this talk?
If you watched the keynote earlier, I would check out the remote development QuickStart for Cloud Code that I showed off there. It allows you to try Kubernetes without all of the tooling set up. So you don't need to worry about language support, SDKs, kube control, Docker, scaffold, all of that stuff. I'd also try adding CI/CD to that sample, just like I did on the keynotes. You can refer back to that if you want to see how.
Yeah, and then likewise, I mean, just like how Cloud Code can make it easier for you to deploy Kubernetes, you can also easily deploy to CloudRun in just a click. So with the link here, you can try it out for yourself. You can take your source code and deploy it directly to CloudRun simply by clicking a button. So I really encourage you all to check that out.
Cool. Well, thanks so much for your time. Thank you for joining us. We are out of time now, but we will be around if anyone has questions.